Hi, IB. We're going to go ahead and talk about a couple rules for logarithms now that we have a basic understanding of what a logarithm actually is. So let's just now talk about our four operations. So addition, subtraction, multiplication, division. How would we take, for example, log 2 plus log 3? What would that actually wind up being? And notice again, we have matching bases. These are both assumed to be base 10. So let's just say that I've let log 2 equal x and log 3 equal y. If I wrote this in exponential form, I'd wind up having 10 to the x equals 2, and also 10 to the y is equal to 3. All right, so let's just think about how I would normally add. If I said 2 plus 3, which would be x plus y, that would be 10 to the x plus 10 to the y. However, I have no way of actually adding those two together because I have the same base, but I have different exponents. And remember, my laws of exponents, I cannot do this. I'm going to put a big X through that, right? I can't just add the bases or keep the same base and add your exponents. However, I have a similar rule where if I multiply the bases, I can add my exponents. So let's just take a moment to take a look at, if I take 2 plus 3, or sorry, change that now to multiply 2 times 3, which would really be 10 to the x multiplied by 10 to the y. I can rewrite that as base 10, and now I can add my indices of x plus y. So really what I've just said is that 6 is equal to 10 to the x plus y power. So now if I take that and I rewrite it in terms of log, so in log form, I have log, again, assumed base 10, I can write it or not, of 6 is equal to x plus y. So now remember though, x was log 2, and y was log 3. And now I'm saying that that's actually equal to log 6. So if you look for a moment at what just happened, I had log 2, log 3, added those together, and that made log 6. So I've just rewritten the equivalent form of that with log 6. And remember, we have matching bases. All of these are base 10. So we can now say that one rule is that if we have matching bases, then log of A plus log of B is really the same as log of whatever the argument is for A multiplied by B. So rule number 1. We've walked through this one with you, and we're going to let you guys try to think through how you might apply the same idea to see if you can prove why the other laws work as well. So rule number 1 for addition of logs. Rule number 2, take a look and see if you guys can try the exact same proof. Try something similar. But if you take subtraction, so log 6 minus log 3. All right. Try this on your own, and notice when you guys look in your book, our second rule is that when we subtract, we wind up dividing. So your challenge is to think, well, why does that actually happen? See if you can come up with an example for it. And our last few rules, log base A to the n power winds up being n multiplied by log of A. Or A to the log base A of 1 is equal to 0, or log base A of A is equal to 1. So just for you guys to think for a moment here. If you were given something like log, let's say we'll keep it base 10 of 2 raised to the third power. What you're really saying is log of 2 times 2 times 2. Now remember, since we just proved that when you multiply your arguments, you could rewrite that as log of 2 plus log of 2 plus log of 2. So what you've really said is that you actually have 3 log 2's. Okay, so notice where that n comes from and where your a remains so that you can prove that that rule actually is valid. And then go ahead and think about the second two rules in the same way and see if you can come up with a proof to kind of just trust yourself. Don't just take it on our word or from the book. All right, so just going through a couple examples so you can see how these rules are applied. I would pause the video here just so you guys can try these 4 examples. We're going to go through 4 of them and try these on your own, and then we'll go ahead and talk through them as well. These first two examples deal with your addition rule and your subtraction rule. So changing your arguments from log base 5 plus log base, log of 5 plus log of 0.4, we'll wind up multiplying 5 by 0.4, and we'll wind up getting log of 2. That is your exact answer. So anytime IB asks you to leave an exact answer, we want to leave it in log form or exponential form, depending on what the question is. If you are going to round, and if you are allowed to use your calculator, then you can round to 3 significant figures, but know that that is a rounded answer. So if your question says leave an exact form or leave in the form, they might say leave it in log form, and they'll give you A and B, and they'll tell you that they want A and B to be integers or whatever the case is. You want to leave it in exact form, but you can use your calculator to round it if that's applicable. Taking a look at our next two examples, we have 1 minus 3 log 2. So notice that you have a coefficient here. So now with our new rule for coefficient, we can do something with that. And then example 4 is log of 27 divided by log of 9. Try these on your own and see if you guys come up with the same answers that we do. All right, so thinking about a question from these about 5 rules that you just went through, try to prove them to yourself, try a few examples, and come to class prepared with a few questions for us. Have a good night.